Hello, it's been a while since we've done a tutorial, but I thought what I'd do today is show you how to run Jupyter notebooks on the compute nodes, and then use SSH to tunnel those connections back to a web browser running on your desktop. So some background. Our systems at UCL are HPC clusters. That means that this is a very high level, and this network diagram is obviously wrong. You have a large number of compute nodes inside a private network. You do not generally have direct access to those. Your access to them is mediated through a batch scheduler. You log into a thing called a login node, which you connect into over the network from your laptop. You package up your work into a job, submit it to the batch scheduler, and it runs on a compute node somewhere. This is great for sort of general scientific workloads, but if you want to do something with, say, Jupyter notebooks, which are interactive, you can request an interactive job, but then you have the difficulty of how you get that traffic back. So, for those of you who aren't familiar with Jupyter, Jupyter is a sort of web interface to Python. What it does is you start up a Jupyter lab session. This runs usually on your local computer, but you can also make it run on a remote machine if you set things up properly. And then you connect your web browser to it, and then you get a nice GUI that you could do your research in. And it's interactive and sort of fun to use. We have to talk about some concepts here to do with networking. So everyone's computer has a thing on it called the loopback network interface. So that means that as well as the real network devices in your machine, like your Ethernet cards or your Wi-Fi card, you have a sort of virtual network called the loopback interface, which is often referred to as localhost. If you looked at it as an IP address, they're the ones that start 127 dot. And we're going to use that so that we're going to forward ports onto that so that it's only accessible from your local machine. And we're going to do that using a feature of SSH which lets you forward ports between machines. So in a machine you can log into, you can forward the port on localhost on that machine to a port on localhost on your machine, right? So when you connect to one, it actually traffic goes encrypted over the network via SSH and connects to the other. There's obviously two ways of doing that. You can set it up so that a port on your local machine is forwarded to a port on the remote machine. You do that with -L, or you can set it up so that a port on the remote machine is forwarded to a port on the local machine, which you do with -R. And we're going to need to use both of those in this example. So how are we going to do this? Well, obviously the first step is to pick a login node. So we have to have a specific login node. When you connect to one of our services, you're usually assigned a random one, but all of the login node, all of the systems we run let you also connect directly to a specific one. So we're going to use Myriad, and we're going to use login 12. And we also need to pick a port number, and for my own personal amusement, I will pick 3270. So we SSH into login 12 with SSH-L, and then in there we prepare a job. So the job will start up on a compute node.
Well, you should have said that. I thought actually we've got something like that this week. So it's like
and that job will start up another tunnel, SSH back to 12, forwarding the ports, and it will also start up Jupyter. And when Jupyter is finished, it will tear down the ports. Okay, so we'll make that connection blue. So that connection comes back. Right. And then on the client, we will start a web browser and connect that to port 3270 on there. So that's somewhat complicated. Let's just quickly go over that again as a list of actions. So we're going to SSH into login node 12 using port forwarding. We're going to actually install Jupyter Lab because just to show that's easy to set up. We'll create a job script that does that SSH-R, starts Jupyter, It writes, so when Jupyter starts up, it prints out a URL which shows you where to point your web browser. Because we're using localhost in all of these instances, that URL will remain the same. But one of the things it has on it is it has a single use token, which is sort of secret, right? It's single use, so after this video, the one that I use won't actually work, but it's effectively a password for your server, right? And you don't want to expose that to other people because if you do, they can connect to your Jupyter instance. So what we're going to do is redirect that into a file that's read only by you. And then the script will, when it exits, shut down the port forwarding. We'll submit the script. Once it starts, we'll connect the browser to the URL in the file. We'll do some playing about with Mandelbrots, and then we'll shut down everything from the browser. So let's do it. Okay, so let's go ahead and do it. I'll log into login 12. So here I'm using the -L, so that'll make a port on my laptop forward to a port on login 12. Picked port 3270, as I said. So let's connect. I like to use a terminal max equals screen, just so I can have multiple shells in the one window. Ignore this step. Right. In my Scratch folder, I have created a folder called SSH demo, and in that I've got a copy of the job script, which we'll have to edit because the paths will be different. I've got a file which tells me where my repository that I've got my fractals program in lives, and I've got a requirements.txt which we can pass to pip to install the packages we need. So first we load Python. And then we'll create a virtual. Okay, we'll activate it. And then we can install stuff from the requirements.txt with -r. It helps if you install it just to show what's in there actually. Okay, that's that installed. So now we need to edit our job script. So this is a fairly normal grid engine job script. We've got our shebang. I've requested 8 cores, though of course if you're doing stuff with GPUs, you might have to request GPUs. 4 gigs of memory and 6 hours runtime. Tell it to run in the current working directory. Now we get into kind of the meat of the thing. So I've put the port number and the name of the login node in an environment variable, so it's easy to change here if I'm logged into a different login node or if I choose a different port. The next line where it says user must move mouse, this is very important. This sets the default permissions that you have on a file you create. And that's important because down here, where we redirect the output of the Jupyter startup, we want that to have permission such that only we can read it, right? So no one else on the system can look at a file and see that secret token it hides in there. Then we load the module. This line here, line 15, we need to change so that it loads the Jupyter lab we just installed. So let's do that. The next line does the SSH that sets up the port forward. So what's happening here? We've obviously got the bit we recognize, which is the -r, then the port we've set, the localhost forward port, and then login 12. What do these do? Well, these set up a set of things where f-f puts the SSH into the background, so it starts SSH and then immediately sticks it into a background process so that you can run the next command. -n says it doesn't actually try to log in and get a shell, it just connects to set up the port forward. -M sets up multiplexing, which we don't need to talk about at the moment, but basically is what allows it to remain alive and allows us to add other ports if we want to. And -S tells it to set up a Unix domain socket in this location and put it in tempter, which we can use to send that copy of SSH commands. And that's important because when Jupyter Lab exits, we want to send this command on line 18, which tells that copy of SSH to stop, right? And that does it by doing SSH-S again for the control socket and giving it the command stop. When Jupyter Lab starts up, we tell it to use the port that we've set, and we redirect all of its standard out and standard error to this file, which has the job ID embedded in it, and should be created permissions such that no one else can see into it. So that done, let's make sure I actually called that virtual env the right thing. Yes, I did. It's Jupyter Lab, all one word. Okay, let's submit that job. Okay. Now we have to wait for that job to run. So while we're waiting for that to run, we can also check out the fractals code. So let's do that. So let's go that file. Pull out of GitHub with git clone. If we look at it, we'll have a folder here called fractals. And this repository I've had this on GitHub for ages, but it's quite nice set of Python code for generating fractal images. It's good because it can output stuff as matplotlib, which means it can be embedded graphically into a Jupyter notebook. Okay, I've actually got a Jupyter notebook that I did with this as a test, which if I get stuck, I can refer back to. But let's see how well this goes. Right, it's now somewhat later and the job is running. If we look in that directory, you'll see that we've got the normal output and error files. And you see what I mean about the permissions? These are created by the scheduler. Doesn't it be a great way to configure that? Now, if you actually look at the permissions of the directory, it's fine because this directory doesn't allow other people to read and write to it. But if you'd set up something so that you were sharing a folder with your colleagues or whatever, that would be a problem if that token was in there. So the script generates this log file with the job ID in it. So if we look at that, you'll see the normal output from the startup. And this is the one-time token, right? So if you remember, I said there's a URL, which in this case is localhost 3270 lab ? And this is a single-use token. So once you've used this, it's useless, right? It stops working. But due to the tiered way in which Jupyter handles authentication, if someone got hold of that and managed to launch the browser before you did, and you'd logged in previously, you would connect to the session, they would be connected to the session, and you would not know that they were also connected, right? And obviously Jupyter lets you run commands as you and arbitrary commands. So let's open that. Let's guess which of the many Firefoxes I've opened is the right one. It was not that one. Let's do that. Right. So if we paste that in, I'll wait a few seconds. So we are logged into Myriad, right? This is running our compute node. It's node 800A051. It's an interesting change in behavior. It seems that now Jupyter Lab starts up a terminal as the first thing, which is kind of nice. So if we do that, we can see that I am on that node. I'm running. As you can see, there's the copy of Jupyter Lab running. There is that SSH session we've got the control of, right? So cool, it's Jupyter. Let's start a Python 3 kernel. Actually, let's not do that here. Hang on. Discard, delete that. Oh, that's nice. It's always good when these things are bug-free. Go into fractals and create a new kernel there. Notebook. Okay. So if we then import the fractals library and do some setup for matplotlib, by default, the plots in matplotlib are not that big. So I am just going to put in some code to change that. So if we import matplotlib I plot as PLT, we just scale these things up by changing the DPI of the images. Oops. Bigger, bigger, big size. Models. That's the wrong one. DPI. See, when you get flustered, you start not being able to do it again. We run that. Cell should run fine because we imported everything properly. And now we ought to be able to simply run calls to my library, right? So I've got an example here, which I think in raw Python, that's not the matplotlib version. There we go. Nice. There we go. This is all running on the compute node, right? It's just bringing the HTML back, displaying it on my local machine. Do more complicated, heavy things if you want to. Let's do this. Let's make these a lot tougher. Let's do 6,000. We've got 8 cores, right? Because we asked for that. Okay, so that all works. I'm going to stop that. So what do you do at the end? Well, if you select shutdown from the menu here on file, what that'll do is that'll cause that copy of Jupyter to exit. That's good because that means that the next step in the script will happen, which is that the SSH session will be torn down. And your job should have stopped. So you now do qstat. It'll still be running for a few seconds. Oh, it's actually properly updated. Okay, it's done. If we look at the output of the job, see this? This is a message from the SSH daemon saying it's torn down the connection. So everything is good. Log out, job done.